Hello and welcome to Excellent Link Academy. For this class, we're considering the concept of fundamental trigonometry identity, right? So for this class, we're considering the concept behind fundamental trigonometry identity. Do well to watch our previous class from the scratch of the concept of trigonometry. So we have begun the study of trigonometry from crash for students that are not that good in trigonometry. So to view our first class and second class, this is our third class under trigonometry. So to watch out our first class and second class using the link you see below in the description of this video, or if you want to, you can go to our playlist and check trigonometry. You see the video arranged accordingly. All right, let's call the concept behind fundamental trigonometry identity. Before I dive into this concept, I need your assistance in something, please. The assistance is that I would like you guys to watch this video at least for 4 to 5 minutes before downloading, please. It helps the growth of this channel. So if you are benefiting from this channel, or perhaps if you have found this channel and this video is helpful, I would like you to assist us with that. All right, let's discuss the concept behind fundamental trigonometry identity. Before I start deriving this trigonometry identity, I would like to recall us back from our very first class of trigonometry. For our very first class of trigonometry, we identify the concept of a right angle triangle. We said let's call this one here theta. This becomes A, B, and C. Let me call this here small a, small b, and small c. This is a what? A right angle triangle. So A to B is small a, B to C is small b, and C to A, or perhaps A to C is small c. All right, let's get the value for the trig what's it called? Trig ratios. What we know for our very first class of geometry is that we discussed the concept of SOHCAHTOA, right? SOHCAHTOA. We have discussed the concept of SOHCAHTOA, right? So let's try to derive this expression again. For S, that's for sine theta. My angle is theta. That becomes sine theta is equal to opposite all over hypotenuse. So what's my opposite? Where the angle is facing, that's B. That becomes B over what? Hypotenuse is what? C, the longest part, C. So note that sin theta is what? B over C. Also cos theta is equal to A over H. That's adjacent over hypotenuse. From here, what's my adjacent? This baseline here, that becomes A. All over hypotenuse what? Longest part, always constant, C. I've gotten sine, cos, and let's get tan, please. So tan theta is equal to what? Opposite all over adjacent, please. From here, what's our opposite? Opposite is what? B. I have B all over. What's adjacent? That's A. I have B over A. So understand this concept of SOHCAHTOA, that sine theta is equal to what? B over C. Cos theta is A over C. Tan theta is what? B over A, right? So at this point here, I want you guys to know something. At this point here, note something, please. Note something, please, at this point. Let's have this one here. Note something at this point. For sine theta, I'm having B over C. Abi now. What if okay. For sine theta, I'm having, all right. At this point here, for sin theta, I'm having B over C, right? So what will observe, please? For sin theta, I'm having B over C. What will C over B becomes? That's the question now. For cos theta, I'm having A over C. What will C over A become? That's the question now. Tan theta is what? B over A. What will A over B becomes? That's the concept. That's the concept now. So now for B over C, listen up please. I'm having sine as B over C. So if I now have C over B, what will it become? We know that cosec theta will always give what? 1 over sin theta. So the relationship between sine will be what? Will be cosec, because we said cosec. This S stands for sine. So this X here is related to sin theta, right? So note that B over C is what? Cosec theta. What's C over A? We know that A over C is cot. What will give us cot? That's what the sec theta. This, if you are familiar with our very first class of trigonometry, you should know why all these are this here, please. All right, I'm having A over B. What's B over A? That's tan. So what will give me tan? That's what? Cot. That's cot theta. So note this concept, please. All right, let's start with the derivation of the fundamental trigonometry identity. All right, first is first, we recall that, recall from Pythagoras theorem, let me call it PT. We recall from Pythagoras theorem, which says that A squared plus B squared is equal to C squared at this point. Recall that Pythagoras theorem says what? A squared plus B squared is equal to what? C squared. So when it comes to deriving the mathematical expression for trigonometric identity, there are about 3 formulas there, which we'll be deriving now. So let's start with the first one. Let's call it case 1. For case 1, divide through by C. So I'll divide through this one by C. So you have A squared plus B squared equal to C squared. We said divide through by C, and by C. Sorry, by C squared, please. C squared, C squared, C squared, and C squared. Of course, from here now, if I apply the concept of indices, I'll have A over C. Sorry, this A over C all squared. These indices, the square comes out as 1 here. So plus B over C all squared is now equal to C over C, next up, all squared. These indices, please. At this point, observe please, at this point, what's A over C? Observe please, A over C is what? Cot, right? Cot. So A over C, that's cot theta. So this one becomes cot theta all squared, right? A over C becomes cot, then this squared. So plus, what's B over C? Of course, B over C is sine theta. So have into sine theta, next up, all squared. So is equal to C over C is 1 all squared. At this point now, note something in science. If I have, observe please, if I have sine theta multiplying sine theta, this is what? Sine theta all squared. Like, so I can write this in this form or sine square theta. They are the same thing. Either I write it in this form or what? In this form, please. So sine theta squared means sine square theta 2. So cos theta squared means what? Cos square theta plus this one becomes sine square theta. So 1 squared will give 1. So this becomes the first mathematical expression for trigonometry identity, that cos square theta plus sine square theta is equal to 1. So this becomes the first one here. I said there are about 3. So this is the first one. That's why I have case 1. Let's discuss about case 2. For case 2, the concept is what? For case 1, divide through by C squared. Case 2, divide through by B squared. divide through by b squared. What do I get? A squared plus b squared is equal to c squared. We said divide through by b squared, divide by b squared, divide by b squared. Apply indices concepts. I'll have a over b all squared plus b over b all squared is equal to c over b all squared. These indices. From here, check. What's AB? AB, observe, AB is what? Cos theta. So have cot theta all squared plus b over b is 1. I have a square to be equal to c over b. Check. C over b is cosec. I'll have cosec theta all squared. From here, cos theta squared can be written as what? I said sin theta squared can be written as what? Sin squared theta. So cos theta squared can be written as what? Cos squared theta plus, this is 1 squared is what? Is 1. Is equal to what? Cosec squared theta. This becomes the second mathematical expression for trigonometry identity, or if you want to, a fundamental trigonometry identity. So this becomes the case 2 under this concept. Let's consider case 3 and end this concept. For case 3, I'll divide by c, b. Let's go with a. So divide by a squared, or perhaps divide through by a squared, please. It means that I have a squared plus b squared is equal to c squared. Divide by a squared, divide by a squared. Next up, divide by a squared. From here, what do I get? From there, what do I get? So from there, apply indices. I'll have a over a all squared plus b over a all squared is equal to c over a all squared. From here, a over a is 1. That will give 1 all squared plus, what's b over a? B over a is tan, right? B over a is tan. You know that I've cleaned the board now, but how do I know? I know that this is b. If I just put b and a down, this is tan. So t tan. So I'll have tan theta all squared is equal to c over a. What's c over a? C over a is sec theta. I have sec theta all squared. From here, 1 squared gives 1. So 1 plus, this is tan squared theta is equal to sec squared theta. This is the last and very important formula when it comes to trigonometry identity. So for an overview, there are about 3 trigonometry identity. The first one is what's it called? Is cos squared theta plus sin squared theta is equal to 1. The second one there is cos squared theta plus 1 is equal to cosec squared theta. And the last one is 1 plus tan squared theta is equal to sec squared theta, as you can see in front of you. So this becomes the concept behind fundamental trigonometry identity. In our next class, I'll be doing like 3 more videos under this concept, still under this concept, but we'll be trying to solve some different examples and proving some identity, right? So we'll be given a question to prove is the left answer equation equal to the right answer equation. We'll try to prove those stuff in our next class and solve some example under this concept of fundamental trigonometry identity. For this class, this is an introduction to this concept. Next class we'll solve some problems, and you see how you can apply these ideas to solve problems. See you in our next class. Thanks for watching.